Welcome to week 12 of 16 weeks of SATs. Now we're nearly there in this 16-week journey of learning everything really that we need to know to be successful in the key stage 2 arithmetic paper. Now this week's video, or one of this week's videos, is all about adding and subtracting fractions. That's exactly what this video is about. So we're going to link a lot of the previous learning that we've got about adding and subtracting fractions, but today's video, as I've said, is going to be about adding and subtracting mixed numbers. So that knowledge that we've got about numerators, denominators, that's all going to come into play as we start to look at how we first of all add a mixed number and how we can go about it really simply, but also the slightly different strategy of how we're going to subtract mixed numbers and the key things that we need to spot so that we can go into that autopilot and solve those questions really effectively. Now, one of the big things I want to ask of you is to please make sure that you subscribe to the channel. There's normally a little red subscribe icon around the bottom of the page somewhere in one of the bottom corners, but it really helps me continue the channel. So please do subscribe. And as we run up towards the conclusion of these videos, please let me know if there are any additional videos and content that you'd like me to cover before SATs get here, because technically we've only got another 4 weeks of videos to run. That's why this week I've put an additional video on as well. So let me know in the comments if there's any additional videos and that you would like me to cover, and please make sure right now that you subscribe. Okay, so thanks very much for doing that. So let's get stuck into it. Adding and subtracting mixed numbers. We'll cover that in a lot of detail with some SATs examples as well, and hopefully by the end of it you'll be able to smash these questions and pick up those easy adding and subtracting fractions, or adding and subtraction mixed numbers, picking up those easy marks. Let's get stuck into it. So with adding fractions or adding mixed numbers more precisely, as you can see here, we've got 2 3/5, add 1 4/5. Now the key thing here, I personally think adding mixed numbers is really simple. All right, there's two parts to this, but adding mixed numbers is much more straightforward than subtracting them, and we'll talk about that in the subtracting part. But we're just going to look at addition ones to begin with. Now, going back to my original fractions statement, when we look at fraction problems, the key thing that I'm always saying is, what is the problem? All right. Now, the problem is normally the denominator. We're looking at the denominator and we're thinking, is it the same? All right. Now, in this instance, in this example, it is the same. So ultimately, with these questions, we're going to go back to our strategy of we need the denominators to be the same. So this example, we're not going to need to do anything. But if we had an example where the denominators were different, we would have to convert the denominators to a common denominator. So to solve this problem, it's really simple. All we're going to do, as a good habit, is we're just going to separate off the whole numbers. Okay, so because we're adding, we can just add, if I just highlight this, we can just add 2 and 1 together and write that down separately as 3. All right, and I'm going to highlight that so we know that this is there for in a second. So really all that we're left with at this point is 3/5 add 4/5. Very simple. So that is going to be 7/5. Very simple. Now that's an improper fraction, so we're going to need to convert because the numerator is larger than the denominator. So to convert, all we do is we work out how many 5s are in 7. So we've got 7/5, as we can see below. 1, 2, 3, 4, 5, 6, 7. We're saying how many of those, how many fifths are in the 7? So we've got, there's one lot of 5. Okay, so that's a whole. And there are 2 remainder. So it's 1 2/5. All right. Now, that was just adding the fractions up. So we've got 1 2/5, but we've also got our 3 over here. So all we need to do is remember to add the 3 back on the whole number. So that 3 add 1 is going to come 4. Okay, so the answer is essentially, as I just changed the color, is 4 2/5. Very simple, very effective way of finding the answers. But it's just, again, having a little bit of composure to just think, right, okay, what do I need to do here? Now, the first problem, as we said, is always looking at the denominators. If the denominators are the same, great, we can just add. And like you say, it just can make it easier to just add the whole numbers separately to start with. So we can just forget about that and then just carry out the problem like we have here in this section. If I just, okay, because this is something that we should be really, really familiar with. Then the next section, which is obviously realizing that we have an improper fraction, and then the next section, which is converting into a mixed number. Then we can add the whole number over here to the mixed number to get the answer. Very, very simple, very straightforward. So as I said in the last one, whenever we see any sort of fraction question, the main thing that we're looking at is what is the problem, okay? And the problem is our denominators are different, okay? So we do need to get the denominators to a common one. Now, again, what we're going to do to make life easy for ourselves is, because we're adding, we can just add the whole numbers together. So 1 add 2 is going to give us 3. So we can mark that over here. Just going to highlight it off again with the blue, so we don't forget that. Sometimes I say put a circle around it, okay, so you just don't forget it visually. All right, and then that leaves us with 1 over 3 add 4 over 6. So again, we need to work out what our common denominators are. So our common denominators, hopefully we can see, are 6. So we would convert to 6. Now, because this fraction here is already 6, we don't need to do anything. So that is just going to remain 4 over 6. With this one, how do we get 3 to 6? Well, we times by 2. So whatever we do with the denominator, we need to do to the numerator. So I'm going to times this numerator by 2. So 1 times 2 is 2. So again, that puts me in a situation of 6 over 6, which is equal to a whole, isn't it? How many 6s are in 6? There's 1. So essentially, we're back in that position where we have the 2 parts to the answer. We have 3 and the 1. So the overall answer is just 4 wholes. I'll just write that in pen. It's 4 wholes. Very simple. If we had an answer box, we would put that in it. Now again, just to go back, the key thing with fractions, any fractions questions, what's the problem? If the denominators are different, we need to find common denominators, all right? And again, we can do that much easily, or much easier, if we just remove and add the whole numbers separately. Okay, so we've added 2 and 1 together to make 3, and then we've just gone into the problem like we would have originally, and we've just solved the problem like we would with a normal fractions question. That's given us the whole number and our final part of the answer to add together. So very, very straightforward. So in this SATs example, again, the first thing that I'm thinking when I encounter this question is, great, the denominators are the same. Now, really, you should just be able to look at this question and just think, well, I can see that this is 1 and 6 over 4. Okay, so there's going to need to be a little bit of a conversion. You can see if we have the whole number, if we forget the whole, there's only one whole number to add. So we could literally just mark that down here. If I just get rid of that, we could mark that down here as 1 as a whole number, so we don't forget about it. And then basically we're just making a quick note of 3 over 4 add 3 over 4. Very, very simple, which is 6 over 4, which is going to give us 1 and 2 over 4. Okay, because this is an improper fraction, so we'd work out how many 4s are in 6. Well, there's 1, there's 2 remainder, and we're still working with fourths, okay? At that point, we would then need, because that is just the fractions part of the answer, we would need to remember to add this part and this part together. So 1 add 1 and 2 fourths is going to be 2 and 2 fourths. So very simply, that would be written in here. 2 and 2 over 4. Very, very simple. And again, now I'm doing a lot of this so you can visually see the process. You might have just looked at this process and went, well, that's 6 over 4. So I'll just make a quick note of it. You don't need to write the whole problem out. You might have went, well, that's just 6 over 4. Because again, this whole space, this whole area is for just, it's not necessary. It's not saying you have to do formal strategies. It's just here for making notes and to help you. So you might have looked at one and went, right, okay, I know that's a whole number. I just need to add this bit together, okay, which is 6/4. I can see that. And then you just maybe making a note going, how many 4s are in 6? 1, 2 remainder. Okay, great. So I've got 1, and I'll add that together. Very, very simple. And again, this is question 25 of the SATs paper. It's very straightforward to do. And again, it comes back to what's the problem? Okay, there is no problem because the denominators are the same. So it's very straightforward to add. Now, again, with this question, the problem that they present us is that they've got the mixed number second, which is a little bit odd. Normally, we would see it presented as 2 and 1/3, add 2/3, which is fine. There's no problems there. And really, all this presentation is doing is just trying to throw us off a little bit and show that we've got a good understanding of what we're doing. Now, again, if we look at this question, it's very, very simple. The best thing about this question is the denominators are the same. Brilliant. If the denominators are the same, it's very, very easy. So I would be looking at this question and thinking, right, okay, well, we've only got one whole number, so that's dead easy. I'm just going to make a note of that over here. I'm just going to highlight it off, and I need to add that on at the end. So essentially, all I'm left with is 2/3, add 1/3. Very simple, which is 3/3, which is equal to a whole number, isn't it? So essentially, all this question is 1 add 2, which is 3. All right, so 2 add 1, 2, this 2, add the 1 is 3. So all we would write in here, annoying, all we write in here is 3. And it's that simple. So this question, very, very straightforward. And again, the key thing is going back to my other lessons around denominators, which are, what's the problem? Okay. If the denominators are the same, it's basically go time, green. We can just add. And by just separating off the whole number, we can make things really easy for ourselves. And again, with this addition problem, if we look at it and go straight into it, now the problem that we potentially have is that the denominators are different. Okay, but it's good that we've spotted that, because hopefully you can see the common denominator is just going to be 10, isn't it? Okay, so we're going to end up doubling this 1/5. It's going to end up as 2/5. But to start with, just to clearly visualize the problem, we're just going to add 1 and 2 together to start with, which is going to give us 3. We're going to make a note of that, just so that we don't forget it for later on to add up. All right, and then we're basically doing 1/5. And again, I'm not doing it in the squares, just so it's a bit bigger so you can see it. Add 1/10. Okay. Common denominator, the denominators are different, so we need a common denominator. We know that the common denominator is going to be 10. So we can add that together. We know that we're going to get tenths. So this fraction is already tenths, so it's going to remain as 1/10. How do we get 5 to 10? Well, I times by 2. So I'm going to multiply the numerator by 2 as well. So 1 times 2 is 2. And as I said, most of you will have spotted that already. So this is very, very simple. 2 add 1 is 3. Okay. So this 1/5 add 1/10 is basically 3/10. All right. So they're the two parts. We've got 3 and 3/10. So very, very simply, we add them together. We have 3 and 3/10. So we're just going to add that into the box. 3 and 3/10, and we get the mark. And the key thing is, the bit here, if we're just on autopilot, we've got to be careful not just to write 3/10 in here. We've got to remember the whole numbers. But ultimately, if we just partition off the whole numbers and add them separately together, it just leaves us with the question type that we're used to, which is basically this, which is a classic. You might just be at 1/5 add 1/10. You know, you might get that 14 questions in. Okay, and you would just find a common denominator. This is all you're doing here. We're just adding the whole numbers separately. So with subtracting fractions, we need to be aware of some different approaches, because we can't always, it does work some of the time, but we can't always just subtract this number from this number, because sometimes the whole numbers, there may only, this question might say 3 take away, 3 and 1/5 take away 7/10. Forget the 1. So in that instance, where we have a problem, because if we had 3 and 1/5 take away 7/10, okay, The problem that we have here is that there's nothing to take away from the 3, okay? So in order to do this problem or to carry out this calculation, we need to convert this number into an improper fraction, okay? So when we see the subtraction problems, the best strategy to apply is to think about, can we just get into the habit of converting to an improper fraction straight away, okay? So to do that, now obviously here we've got the other issue that the denominators are different, so we will need to find a common denominator. But in order to convert, what we do is we take the denominator and we multiply it by the numerator. Sorry, the whole number. So we do the denominator times the whole number, and then we add the numerator, okay? So we would do, for this fraction, we would do 5 times 3 is 15, add 1 is 16. So this fraction, 3 1/5, is actually 16 over 5, okay? Take away. And then we do the same on the other side. 10 times 1 is 10, add 7 is 17. And what that does, it gives us the improper fraction of 17 over 10. Now, really, the reason why that is, okay, is because if we think about this, essentially what this 3 represents, for example, is basically 3 lots of 5/5, okay? So if we have 5, I'll do it over here. If we have 5 over 5, then that's equal to a whole. If we have another 5 over 5, that's equal to another whole. And if we have another 5 over 5, or 5/5, that's equal to another whole. So essentially here, we have 15/5, which is equal to 3, isn't it? So if we have 15/5, okay, if we worked out how many of the denominator and the numerator, well, that's equal to 3, isn't it? Okay, so that's what this 3 actually represents. So by doing 5 times 3, all we're doing is expanding out this whole number into a fraction. So there's 15/5 over here. 5 times 3 is 15. And then we add the 1/5, which is 16/5. Okay, so that's just getting into the technicalities of what's happening there. All right. But ultimately, all we need to remember if in the SATs is we need to just get into this habit of when we see a subtracting fractions mixed numbers question, is if there is a mixed number here, we times the denominator by the whole number and add the numerator. And that gives us this situation here. Now, again, that just puts us back in the situation of the denominators are different. So we need to find a common denominator. So now you're so good at this by now, you know that the common denominator is 10. Okay. We're just losing a little bit of space. But this problem, how do we get to 10? It's already a 10th. So this is just going to remain 17 over 10. How do I get 5 to 10? Yeah, well, you can already tell me we're going to times by 2. All right. So that means we're going to times the numerator by 2. Exactly what we've been doing in all the other fraction problems. So we're just using a skill that we've been using a lot already. And that leaves us with 32 over 10. Take away 17 over 10. Which leaves us with 15 over 10. And at that point, what we need to do, because we've got an improper fraction, we need to work out how many 10s are in 15. So it's very, very simple. We'll just take it down to the bottom over here. We've got 15 over 10. How many 10s are in 15? Well, there's 1. How many remain? 5. So it's 1 and 5/10. Or we could simplify that to 1 and a half. Okay, but either of these answers, okay, will get you the mark. All right, this is just an equivalent fraction. So again, it looks like we've done a lot of work, when in reality we haven't, because all this information over here was just me doing a little bit of explaining. All right, but essentially all we've got here is a really straightforward strategy of multiplying the denominator by the numerator, denominator by the whole number, add the numerator. Okay, so it's times, add, times, add. All right, and that gives us this situation here, which is very, very familiar from all of the other arithmetic videos that we've done. Okay, very, very, very straightforward. Okay, so again, with this question, the first thing that I'm encountering or that I'm thinking about when I see it is that my denominators are different. I'm always looking at the denominators in any fraction question. If they're the same, fantastic. If they're not, I know that I'm going to need to find a common denominator. And in this instance, we know, or we should be able to just see 3 and 9 and know that 9 is going to be the common denominator. 9 times table is 9, 18. We don't need to get that far. And then we've got 3, 6, 9. So we know 9 is going to be that. But because we've got a subtracting mixed numbers question, we're going to need to convert the mixed numbers into improper fractions. And that's really important. So we do that by just timesing or multiplying the denominator by the whole number, add the numerator. Okay, so again, there's a little v in there to a certain extent. I'll just pop that in. Okay, so it's times and add. All right, so I'm going to do 9 times 1 is 9, add 8 is 17. Very, very simple. So we've got 17 over 9 and get into the habit of rewriting. I'm going to do the same on this side. 3 times 1 is 3, add 2 is 5. So I've got 5 over 3. Very, very simple. Now at this point, I know that I'm going to need to convert and find a common denominator. Fortunately, it's 9. So I don't need to change anything to do with the first fraction because that's just going to remain ninths. So it's just 17 ninths. And then again, how do I turn 3 to 9? Well, I multiply by 3. So 3 times 3 is 9. So I need to do the same to the numerator. So that 5 times 3 is 15. Okay, and then very, very simply, that leaves me with my answer. Okay, so I'm going to do 17 take away 15 is 2. So the answer, really simply, is 2 over 9. Very easy, very straightforward. And again, we just need to get into that habit of just autopiloting back into, you see the mixed numbers, and all we need to do is multiply and add. And that's going to put us back into this position where we're really familiar with. We need to adjust our fraction here to a common denominator, and then we adjust the numerators. Really, really simple. And if you're not sure on that, go back to some of the other videos on the channel, and there's specific videos about adding and subtracting fractions. So you can practice that skill, and then you just use this skill within these problems. So ultimately, they're very easy to do, very easy marks, and you're always going to get two or three of them in the arithmetic paper. So if we look at this SATs question now, the first thing that I'm spotting with this question is that the denominators are different. Okay, so again, that's me going into autopilot and thinking at some point I'm going to need to find a common denominator of 5 and 15. Well, I know that in the 15 times table, even though I don't know the 15 times table off the top of my head, I can maybe work out the first two, but it's obviously 5, 10, 15. The common denominator is going to be 15. All right, but I know I'm going to need to work with that at some point. Now, the second part is knowing that I'm going to need to convert, because it's a subtraction, and this is, we've got to go into this autopilot, subtraction of mixed numbers, or a mixed number and a fraction. I need to convert this mixed number to an improper fraction. So I need to do the denominator times the whole number, add the numerator. So I'm going to do 15 times 1. I'm just going to write the question out a little bit larger. 1, 1, and 1 15th, take away 2 fifths. Okay, so 15. Oops, I've just got rid of that. So 15 times 1, add 1 is 16 over 15. So 16 over 15, take away 2 fifths. Now I know that I need to then make this common denominator into 15ths, don't I? So I'm just going to use this over here. And again, you don't need to take up all the space. I'm just doing this so that you can see it. So I've got 16 over 15. Just going to rub that out because that's really messy, Andrew. 16 over 15. Take away 2 fifths. Just getting into the habit of writing this below, because this is what we always do. It's 15ths. So I can leave this one the same, because it's already 15ths. And then I'm thinking, how do I turn 5 to 15, which is times by 3? So I need to times the numerator by 3, which is 2 times 3, which is 6. So I can write that in, and then I'm in that perfect position of the denominators are the same. So I can just subtract. 16 take away 6 is 10. So I'm left with 10 over 15, which is just going to be my answer. Very, very simple. 10 over 15. That would work. You could reduce that down and simplify it into 2 over 3, but 10/15 will work. But again, it looks like there's a lot of working out there, and I'm just really showing you everything that you need to see. But ultimately, some of you will be able to work through that much quicker by just making little notes as you go. But ultimately, the key thing is spotting that when we have a mixed number involved and we're subtracting, we need to convert the mixed numbers by multiplying the denominator by the whole number, add the numerator. That's going to give us this situation here, which we like. And then we can just go into that habit of finding the common denominator and doing the process that we know how to do. Really simple. So with this question, again, relatively straightforward. That again, we have a situation where we've got a mixed number and we're subtracting a fraction. Now, the first thing that I notice that I need to be aware of is the denominators are the same, which is absolutely perfect. It means I'm not going to need to find a common denominator. The only thing that I really need to do is I need to convert this number, because I've spotted that we're subtracting and it's mixed numbers involved. This mixed number needs converting to an improper fraction. So we've got 1 and 3 over 7, take away 4 over 7. Fantastic. So now I'm going to do 7 times 1, which is 7, add the 3, which is 10. So this fraction is now 10 over 7, and I'm taking away 4 over 7. Perfect scenario. I've got denominators that are the same. Wonderful. I can just do 10 take away 4, which is 6. So I'm left with 6 over 7. And that is the answer, 6 over 7. And that would get me the marks. So again, it's really, really straightforward. But we just need to go through the process, especially when it's subtracting fractions, of knowing that we can't just segment, or in some instances, so there are some instances where you could subtract the whole numbers and then subtract the fractions and it would work. But there are other examples where it doesn't work. So sometimes the best thing to do, especially for our stats, for consistency, is just to get into the habit of converting them anywhere by doing denominator times the whole number, add the numerator. That puts us into this situation here, which is very, very familiar, and we can just get the answer without too much stress. And again, another example of a mixed number. I think what the SATs questions tend to do is when it's a subtraction question with a mixed number, it is a mixed number, take away a fraction, all right? Whereas the addition ones tend to maybe have two mixed numbers. It's not always true, but these are the examples that I've found, and this seems to be ringing true. Okay, so it's a little bit of a trend in there. So again, the first thing I'm spotting is my denominators. I'll just remove that so we can highlight it. My denominators are different. So at some point, I'm going to need to find a common denominator. But obviously, the common denominator of 2 and 4 is 2. So it's 4. So it's very, very straightforward. The next problem is just making sure we've got this mixed number. We're going to need to convert it. All right, so let's go through the process. So we've got 1.5. Let's just change that. Andrew, you've made a mistake there. It's not like you. So 2.5. 2.5, take away 3 over 4. And that's just a good example as well of, okay, I'm teaching this lesson essentially, but sometimes we all do lose a little bit of concentration and focus, but it's okay if you make a mistake. Don't give yourself too much of a hard time. Let's just correct it, make sure that we are correct, and move on. So again, we've got 2.5, so I'm going to convert this mixed number. 2 times 2 is 4, add 1 is 5. So we've got 5 over 2 here, take away 3 over 4. And again, we can go straight into knowing that the common denominator is 4. We should know that. We should be able to see with those two numbers what the common denominator is. So from that point, we can just adjust. So this fraction is already fourths, so that's just going to remain the same, 3/4. This fraction, how do I get 2 to 4? Well, I times by 2, so I'm going to do the same to the numerator. So the numerator, 5 times 2 is 10. So that gives us 10 over 4. So we've now got a situation where we can perform a subtraction. 10 take away 3 is 7. So we're left with 7 over 4. I'm just going to write that up here. And again, if we had 7/4, 1, 2, 3, 4, 5, 6, 7, and we said how many 4s are in there, There's one group of 4. How many remain? There's 3 over 4. Okay, because we're essentially saying how many 4s go into 7? Well, there's 1. How many remain? There's 3. So that's the new numerator. And we're still working with fourths. So the answer is 1 3/4. Okay, so we need to write that into the box. And again, relatively straightforward. There's nothing in there that's complicated. The only extra step from all of our other fractions questions is converting this mixed number into an improper fraction by doing 2 times 2, add the numerator. Okay, so very simple, very effective. And again, our final SATs example, nothing too complicated. Okay, again, first thing that I notice is the denominators are different. And again, with the denominators as 2 and 3, it's just jumping straight into my head that the denominator is going to be 6, the common denominator. All right. The next problem is the fact that we need to convert this mixed number. So we're going to do that. Let's go ahead. So we've got 2 every time. 2 and a half, take away 2/3. So again, 2 times 2 is 4, add 1 is 5. So we're in the same situation as the last question. So we've got 5 over 2, take away 2 over 3. And again, we know that the common denominator is going to be 6, so we can go straight into autopilot. Okay, so again, how do I get 3 to 6? Well, that's times by 2, so I need to do the same with the numerator. So that's going to be 4. And then again, how do I get 2 to 6? Well, that's times 3 or multiply by 3. So I need to do the same with the numerator. So 5 times 3 is 15. And that puts me in a position where we're green because the denominators are the same, which is fantastic. So we can do 15 take away 4, which is 11. 11 over 6. So I'm just going to bring that up here so you can see it. 11 over 6. So again, we've got 11 sixths. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many lots of 6 are in 11? Well, there are 1, 2, 3, 4, 5, 6. So we've got 1 lot, and then there are 5 there remaining. So we've got 1 whole. How many 6s are in 11? 1. How many remain? 5. And we're still working with 6, obviously. So the answer is 1 5/6. And again, very, very simple, very straightforward, using all the skills that we know already. The only new skill that we're using is converting this mixed number into an improper fraction. Very simple, but very effective. And just to finish with some very, very simple, well, I say very simple, probably more complex than the SATs questions. Now, I think with the addition problems, you will get the need to do questions like this in the SATs. But again, what we're looking to do is we're looking to partition off the whole numbers and add them separately. So in this first question, I'd be doing 1 add 2 is 3, and I'd be making a note of that at the side. In this question, I'd be doing 1 add 1, and then that leaves me with the standard question of 1 over 3, add 2, or add 3 over 4, which is something that you all know how to do. All right. And again, with the subtraction questions, these are probably more difficult than you're going to encounter in the SATs. But if you can do these, it's very straightforward. Ultimately, the key with all these questions is, and again, these ones, if you can do this row here, that's probably the most important. These ones, you're going to end up with some quite large numerators and denominators. So if you get to this side, especially from this one onwards, this 4 and 4/5, don't get disheartened if these ones seem a little bit difficult, okay? Absolutely have a go. But if you're finding really large numerators and you're struggling to divide them, etc., don't worry about it, okay? Because as you've seen in the SATs questions, none of them are these difficult, all right? But I just thought I'd put them in there anyway. So again, good luck with these. There's definitely not 4 or 5, but there's at least 2, maybe 3 marks available for adding and subtracting mixed numbers. So it's definitely worth practicing. And these questions are normally going to come from sort of question 25 onwards. But again, with the subtraction question, just remember, with each mixed number, we're just converting it by timesing the denominator by the whole number and adding the numerator. As long as you can remember to do that on the subtraction questions, you will be 100% okay and you will score those marks in your SATs. So adding and subtracting mixed numbers, I would suggest that this is probably one of the more complex strategies or approaches that we've looked at, but ultimately I hope you also feel confident now in approaching these questions. The adding mixed numbers strategy is very, very straightforward. It links back to all the other strategies we've used before and our knowledge of whole numbers, the denominator and the numerator. Very simple to just partition and add. Super, super simple. And again, looking for that denominator either being the same, and if it's not, going into that process of finding a common denominator. And then with subtracting fractions, we just use that slightly different strategy to multiply the denominator by the whole number and add the numerator. And that's going to help us get to that answer very, very quickly. So that's it for this week. As I said at the start, please make sure you subscribe to the video. Let me know in the comments if there's any other areas that you'd like me to cover in the next 4 or 5 weeks before we get to SATs, because I want to make sure that I've covered things that you're maybe struggling with or things that you'd just like to see more of. So definitely let me know in the comments and subscribe to the channel before you leave this video. So well done this week. Well done for continuing to get stuck into these questions and these new strategies, and you on your way to being super successful in your SATs.